Well, hello, and welcome to your first thermodynamics session of the block. I'm asking that you will have been to the wiki and downloaded this syllabus and watched this video before we even have our first class meeting. So, if you don't recognize my voice, this is Ron, and over the course of the next 8 to 10 minutes, I'm just going to walk us through the thermodynamics syllabus. What you can expect from the course. You can expect to acquire the core knowledge of thermodynamics for use in your future career problem solving. I believe that the primary task of an engineer is to solve open-ended problems for your company, your client, yourself as an entrepreneur, and that to perform that open-ended problem solving requires that we have a background knowledge of the core principles. And here they are for thermo: the first law, the second law, conservation of mass, cycle analysis, and property relationships. Now, to learn those, we'll actually learn a few more things along the way. First law of thermodynamics is not new. You had it in physics, you had it in dynamics. It's the law of conservation of energy. And all the rest of this either supports or comes out of the work from the first law. Also, in this course, you can expect to apply fundamental principles to engineering solutions and everyday problems. You're going to have the ability to ask questions, and I anticipate that we'll spend the first 15 minutes of every learning conversation with you asking questions, and I will give you feedback on your development. And at the end of the course, I will give you an oral exam grade sheet and a grading sheet for the course. In fact, the grading sheet for the course will be this syllabus. This is why I want you to print it out. You and I are going to sign it. You'll bring it to your oral exam, and I will fill in all of the grades for all of the different areas in the deliverables, sign it, give you your grade, and hand it back to you right at your oral exam. So that's what you can expect out of the course. Here's what I expect. I expect that you are motivated to embrace thermodynamics as essential engineering knowledge that you will need in your career. And I absolutely 100% honestly believe this. I believe that there is nothing more important than understanding how energy enters into or leaves or accumulates in any system: electrical, mechanical, biomedical, civil, you name it. Energy is what drives or is driven, either causes the driving or is the result of the driving of any system. I expect you to be at class fully engaged every day, on time. We're going to have you learn inside and outside of class. You can anticipate that we will, for every 1 hour we spend together, I will have 2 hours of work for you to do outside of class. The only way that this knowledge is of any value to you is if it's available 6 months from now, a year from now, and the only way that happens is if you practice encoding so that it can be available to you. I want you to monitor the acquisition of your knowledge and the development of your own self-directed learning abilities. And I want you to learn to self-identify and access other learning resources. It's not just about what you hear from me on the videos, what we do together in class. It's not just about your textbook. It's about finding other resources. So I'm going to encourage you to do that. The deliverables for the course. There's going to be an oral exam and a DLA turned in at the end, a learning plan turned in at the beginning. There will be some problem sets. I will give you a reflection to do almost every day. I will ask you to practice describing principles almost every day. I'll give you 100 points for being in class, being engaged, and really putting forth effort. And at the end of the course, there will be a learning report for a total of 1,000 points. If you do a little quick math there, you'll see that this only adds to 900 points. So I ask you to take this additional 100 points and put it wherever you want it in this table. If you'd like to put all 100 points in one of the areas, great. If you want to put 50 points in one area and 50 points in another area, great. But do so before you and I sign the syllabus. So you'll do it, we'll sign it, and that's how your grade will be determined at the end of the semester. There is more information on the wiki, lots of videos. All right, so that's the syllabus. If you have any questions, jot them down and ask me at our first learning conversation. I'm now going to go to another document to talk a little bit more about our expectations in the course. This is a document that I've made for myself. I don't give a copy of this out. It's more my planning document for our course. But here's the bottom line. Long after this course ends, I would hope that you still are able to do these things, these 4 things that are listed in this box below. And I've arranged all of our time together and all of your assignments to be focused solely on being able to do these 4 things. And the first, as I already mentioned, is to apply the first law to the widest variety of systems by balancing energy additions, subtractions, and accumulations. Second, I want you to be able to describe the first law, describe property relationships, describe work, heat transfer, power, enthalpy, entropy, Rankine cycles, refrigeration or air conditioning cycles, same thing, the second law, and the conservation of mass. Now you can see that 5 of these are italicized. That means that they are from the fundamental principle list at IRE. These are the 5 that in your final exam, your final oral exam at the end of the semester, this semester and all the semesters into the future, we're going to ask you to be able to describe these things. Third, I want you to be able to solve some basic problems. We'll practice those. And I want you to apply your knowledge from this course to solve the complex open-ended engineering problems that we face every day. In order for us to be able to apply these things well into the future, we're going to practice them throughout the course. There will be in-class and out-of-class activities. First thing we're going to do is acquire the knowledge, and as I will tell you in our first learning conversation, our time together in class is too precious for me to spend a third or a fourth of it or a half lecturing new material. So instead I'm preparing these videos, and I'll have some readings, and we'll acquire this knowledge outside of class so that when you come to class we can talk about it and process it. To achieve our goals, we will provide many scenarios to goal number 1, where the first law can be applied. We'll identify the system borders, how energy crosses the borders, and how it accumulates. This is the most important thermodynamics skill that we'll use in our career. To achieve goal 2, we'll be able to describe these items long into the future. I'll have you do written describe sheets. I'll have you practice verbal describes in and out of class. And I'll expect you to be able to describe any of these 12 items on the oral exam. So it's essential that you ask me questions during class to help clarify your understanding of the concepts. The thermal problem sets that we'll do, and I've got about a half a dozen. Number 1, so you can see how the thermo is applied, and 2, to prepare you for the FE exam should you choose to take it. As such, we'll have time to do these things. Engineers who use thermodynamics in their career will do so to solve open-ended problems. To practice this skill, we will identify and complete a deep learning activity. And I've got a bit of a calendar here that shows our 14 or 15 days together. And this is weeks 1 and 2, weeks 2 and 3, and already we are going to start talking about your DLA right here on the 5th day of class, and I'm going to have you write the introduction to your DLA report that day. So we're going to get to the DLA early. You'll see that on this calendar, and again, this is just my guide. I have what we're going to do in class. I have what videos I want you to do before we get to class, and I have ideas of what homework assignments I'm going to give you outside of class. All right. Well, that's it. Thank you for watching this video. Before you come to class, again, take a few moments to write down any questions that you have so that when we get to class, we can spend time answering your questions.